Right, let's say that this x variable represents, let's say, hours. And let's say I have a job where I assemble robots. So I assemble robots, and y represents how many robots I have next to me that I put together. Well, at 3 hours, I have 12 robots assembled. Now that doesn't mean that I assembled those 12 in 3 hours, it just means that at the 3-hour mark, I have 12 robots. What tells me how many I've built at what rate, like how fast am I building these, I have to look at some change. I have to see actual change. So I look and I see that the hours that have gone by between 3 and 4 is 1 hour. Just the hours changed by 1. When I look at how many more robots I have, well, I had 12, and now I have 15, so that's 3 more robots than I had a minute ago. Well, 1 minute ago, or sorry, 1 hour ago. So in 1 hour, I've assembled 3 more robots, okay? Well, let's see what happens in another hour. 1 more hour, I go from 15 robots to 18 robots. 3 robots that I built in that hour. So I can see pretty quickly I'm building 3 robots per 1 hour. So if I wanted to predict how many robots I've made after 7 hours, easy enough. Well, that's 1 hour after 6 hours. And I've been building them 3 robots per hour. So in this 1 hour, I should be able to build 3 more, which takes me from 21 to 24. Let's say I want to make a bigger jump. I want to jump from hour 7 to hour 20. Okay, so from hour 7 to hour 20, how many hours is that? 20 minus 7 gives me 13 hours. So 13 hours later. All right. So maybe this is my total number of hours in a week or something. So 13 hours of robot building at 3 per hour. Well, I wouldn't just add 3, would I? I would add 3 several times. I would add 3 to get to the 8th hour, 9th, 10th, and all the way up. I would keep adding 3 for every hour that passes. And 13 hours pass. So 3 per hour times 13 hours, right? So I'm going to have 39 more robots built. 39 more robots means I have 63 robots built. Okay, so after 20 hours, I will have built 63 robots. All right. So now we want to generalize this for any number of hours. How many robots will I have built? All right. The most simple, plain way of putting this, the way that I would do it most of the time, is simply I would back up to before I started. Okay, hour 0. Hour 0, how many robots did I have? Maybe these were left over from a previous day, or maybe these were ones that somebody gave to me to assemble, or I don't know, whatever the case may be. Before I started assembling them, for some reason, I had some in the beginning. So go back to 0. How do we do that? Well, that was 3 hours, right? Ooh, if I start at hour 3, if I go back 3 hours, I'm at 0 hours. Count it off on your fingers if you want. Go back to hour 2, hour 1, hour 0. We back up 3 hours. And each hour, I'm able to assemble 3 robots. So 3 robots per hour times 3 hours that I'm building these robots at 3 an hour, that's 9. Right? So I back up 9, which means I back up from 12, back up 9 from that. I must have started with 3. All right, so maybe a friend of mine who's very fast at building robots, he gives me 3 to get me started for some reason. Just means that before I started assembling any robots, before any time passed, I just had 3 robots already assembled. Then I started building 3 an hour from there. So if y represents the number of robots, it's always going to be equal to, if I start with the 3 robots that were there before I started at hour 0, well, to get to the next number of robots, I would add on a 3. If I wanted to go several hours down the line, I would add on 3 multiple times, or I would add 3 times some number. What number? If it's hour 1, then that's 1 hour later. 3 plus 3 times 1 is 6. That's naturally how many I would have the next hour. If it was 2 hours, right, I would plug a 2 in there. 3 plus 3 times 2, that's 3 per hour times 2 hours. 6 more, right? 3 plus 6 is 9. If it was hour 3, 3 hours at 3 robots an hour, plus the 3 I started with, that gets me 9 plus 3 is 12, just like it says right here, hour 3, 12 robots. So it looks like all I have to do is plug in the number of hours, right? And X represents the number of hours. So this should work for any number, and we could test it. If you're ever wondering if your formula works, try it and see if it works. So 3 plus 3 times, let's try 6, right? Y equals 3 plus 3 times 6 is 18. 18 plus 3 is 21. 21, right? Does it work for 20? 3 plus 3 times 20, that's 3 plus 60, 63. 63. So yeah, it works perfectly. It tells me exactly how many robots I will have after X number of hours. For this one, let's say I'm making it my goal to every month, or tracking it by month, to see how many trails. There's a lot of trails I can hike in the Missoula area throughout the Bitterroot and Rattlesnake and just all over the place. So I'm going to see how many trails I can hike, and I'll just keep track of it each month, okay? So we say month 7, I have visited 39 trails. That's a lot of trails. A month later, month 8, I visited 45, so that's 1 month later. And how many more trails have I visited? I visited 6 more trails. Okay, so it looks like in 1 month I visited 6 trails. Let's see if this trend continues. 1 month later, month 9, I've gone from 45 to 51. That's 6 more trails that I've hiked. So I'm visiting 6 trails every month. 6 trails a month. So at that rate, how long or how many trails will I have visited, after 12 months? After a year, how many trails will I have visited? After 2 years, which is 24 months, right? I should be able to project that out into the future indefinitely for as long as I want. So we want to write a formula for that, right? We could just follow the pattern, right? 10th month, go to the 11th month, that's 1 month later, which means I know that I should see 6 more trails. Okay, 6 more trails than 57 would be 63 trails. If I want to go further than that, I want to go to month 24, right? For a whole year. Let's start at 11. Okay, well that's how many more months is, so not a full year, 2 years. Not 1 year, but 2 years. Okay, how many more months is that from the 11th month to the 24th month? Well, 24 minus 11, that's 13 more months, right? So a year and 1 month extra. Okay, what does that amount to how many more trails I'll visit? Well, every month I visit 6 more. And I'm going to visit 6 more for 13 months straight, right? So how many more trails will I visit? 6 times 13, which is 78. Okay, well that's 78 more than I had visited back here at 11 months, so 63 plus 78 is 141. Just double checking that. 141. So after 24 months, I should expect to see 141 trails, and I should be able to project this out, but I don't want to keep doing it this way, just hopping through 6 trails at a time, or big jumps and having to add it on to that amount and whatever. So let's just be a little more efficient about it. Again, the best way that I can think of is to back up to 0 months. Okay, before I started this whole thing, how many trails had I visited? I'm sure I had hiked some trails before I got it in my mind to just see how many trails I can visit. consistently over the months. Um, so if I visit six new trails each month, um, and at month 7 I'm at 39, then what does that mean about the number of trails I had visited before I started? Um, well, let's jump backwards to 0, right? Well, that's 7 months. Right? From 7 months back to 0 months, that's 7 months. Okay, well, I had been going at a rate of 6 per month for 7 months. So that's 6 times 7. 6 times 7, that's 42. So 39, I back up 42. This is kind of weird, but I actually was at -3. Okay, so this example of months and trails, how do I visit -3 trails? Maybe I walked backwards through them. Sorry, I didn't realize it was going to go negative, but maybe we can have something that's negative. What could be negative? Okay, let's just say instead of all the trails business. All right, so all the numbers are the same, except we're going to change it. Instead of how many trails can I hike, it's how many cars do I sell in that month. Okay, so cars. All right, how many cars can I sell? So maybe I own a used car lot, and I want to see how many cars I can sell in a given month. How can I have -3 cars? Well, I guess maybe I had bought 3 cars, right? And so that was money that I wanted to make back, and so I want to sell cars to make up for that. So maybe that was it. I'm in debt 3 cars in some way. But I can start from -3 cars and go up from there, right? It goes up, it doesn't go down, so I would add on 6 cars to get to the next month. And I would add on 6 more cars to get to the month after that, and 6 more cars to get to the month after that. Right? And since I start at month 0, this is why I recommend that you go to month 0, then I can just say, well, I'm selling 6 cars per month. X months are going to go by. If 1 month goes by, that takes me from month 0 to month 1. If 7 months go by, that takes me from month 0 to month 7. And if 10 months go by, that goes from month 0 to month 10. Let's test it out and make sure it works. Y equals -3 plus 6 times 10. So this should tell me how many cars I've sold after 10 months, right? Starting with -3 cars, adding 6 cars per month. That's 6 cars per month for 10 months. So, well, that should sell 60 cars. But I have to add it to the -3 I started with. So y equals 57. Exactly as it's supposed to be. Okay, let's work the next example. Okay, so for this example, let's say that I'm a book manufacturer, and this X here represents, let's say it represents hours, okay? And let's say this represents the number of books, okay? So think of it as books that, as a publisher, I've assembled, right? Printed the pages, assembled the book, glued it all together, all that kind of stuff. And so we are increasing in books because we're making these books, and this is how many books we have to sell, like our inventory of books. Okay, so that's just another example, just trying to be kind of creative, but you may or may not like that example. So after 8 hours, I have 31 books, okay? That does not tell me anything about how fast I am at printing books. I could be really slow and just have extra books from a long time ago, and I just have extra. So I have to look at the actual change. How much is this stuff changing? Well, I have some information about a later time. At 15 hours, I'm up to 59 books. Okay, so well, how many hours is that? Well, 15 minus 8, that's 7 hours later. So 7 hours later, what's happened with the books? Well, how many more books do I have? 59 minus 31, that's going to be 28. So in 7 hours, I've made 28 books. Okay, so maybe kind of a small-time mom-and-pop book manufacturer. Well, if in 28 hours if in 7 hours I've made 28 books, then how many books can I expect to have made in a day, or which is, let's say that's a 12-hour day that I'm running the machines that make books, or after a week. Okay, so 12 hours a day times 5. So after 60 hours of running the machines, how many books will I expect to have, and so forth. This problem's a little bit different from the ones we've done. Slightly more challenging because, I could go 7 hours in the future and know that I should have 28 more books, right? Which isn't even what happens here. It goes from 15 to 20, it goes to 5 hours in the future. That's kind of weird. 5 hours into the future, and how many more books do we have here? We have, looks like 20 more books, okay? Well, then we go forward in time 7 again, and what do we see here? We see it goes up by 28 again, which is good. We would hope that if 7 hours go by again, 28 books would be made. But, what if I want to know after 28 hours, how many books will I have? It's hard to say, because I only have really information on 7 hours going by. I know I should see 28 books be made. 5 hours going by, I know I should see 20 books being made, but after that, what should I expect? So what would be really helpful is, instead of just knowing that we're making 28 books per 7 hours, it'd be helpful to know how many books we're making every 1 hour. Well, if we make 28 books in 7 hours, that must mean that we make 4 books in 1 hour. Every hour we must be making 4 books. If in 7 hours we make 28 books, that makes sense. 4 books an hour, 7 hours, 28 books. And that's going to be helpful to know, because if I want to know how many books have I produced in the 28th hour, that's just 1 hour away from the 27th hour, then how many books will I have? Well, now I know that's 4 books per 1 hour, so 1 hour later I'll have 4 more books, which puts me at 111 books, right? So that's helpful. Now, to create a formula that will do this for any number of hours later. Okay, again, very helpful to go all the way back to where it all began, hour 0, right? Where no time had passed yet, no hours had gone by. How many books did we start with back then? That allow us to work up at a rate of 4 books an hour to get up to the point where at 8 hours we had 31 books. Let's try thinking of it this way. From 0 hours up to 8 hours is 8 hours, right? Go up 8 hours from 0, you're at 8 hours. How many books would that be from this number that we don't know yet to get to 31? Well, for 8 hours, we've been making 4 books every hour. That's 4 books times 8 hours. That's 32 books. So in 8 hours, I should be able to make 32 books, and yet I only have 31. Okay? Well, that must mean that I started with -1 books. How could I start with -1 books? Maybe I owe someone a book, right? I already owe someone a book at the beginning of the day because they paid for it at some point, and I haven't made it for them yet. Okay, so once I make that book, I might have a book, but really, I'm kind of just 0 books once I make that 1 book for them. But after that, after I make that first book and continue on from there, I'm in the positive after that, right? So I make these 32 books, but I only have 31 to sell because one of the books, right, was owed to somebody else. That's how we can make sense of a negative number like that. So I've made 32 books in 8 hours. The total books I can actually sell is 31, right? But after that, 4 books an hour. Boom, 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 boom. 7 more hours, 28 more books, 5 more hours. 5 times 4, 20 more books. Add on 20 books there. So on and so on. 4 books an hour, okay? So if I want to figure out how many books I have after X hours, Well, I should start with that -1 book, right, where no time had gone by yet. Start with that -1 book and start adding from there. Adding 4 per hour times the number of hours, right? Times 1 would take me to 1 hour, times 8 would take me all the way to 8 hours, right? Y equals -1 plus 4 times 8, that's -1 plus 32, that's -1 plus 32, 31. It's working just great. So all I need to do, since I'm starting at 0, right, the number of books at 0 hours, I just need to add 4 times the number of hours that go by. And that should do it. And if I tried it again for 27, y equals -1 plus 4 times 27. Y equals -1 plus 100 and, let's see, 108. 108. -1 plus 108, 107. There we go. So it's working just fine. Let's take a look at this one. I think I have a good one for this guy here. Let's say that x is seconds. Okay, now imagine we work for a super secret facility. And whenever you work in a super secret facility, it's all underground, right? The building you work in is mostly underground, right? So we have to go way, way down in the earth and do things in super secret. So let's say that this represents the number of floors, right? Or which floor I'm on, okay? So, I get in the elevator. 2 seconds later, I'm on the 8th floor. But that doesn't really help me because what floor did I start on? We'll have to figure that out. But here's something I know. 6 seconds later, what's happened? I've gone down 20 floors, right? From the, no, excuse me. We've gone from 8 down to -28. So we've gone down at 28, 8, 36. Okay, so in 6 more seconds, I've gone down 36 floors. I've gone past the first floor, past the basement, past the sub-basement. I'm into the super secret sub-levels. Okay, I'm at the -28th floor, right? And what happens now? 4 seconds later, I am at the -52nd floor. So that means I've gone down another, let's see, another 24 floors down into the earth. And this pattern keeps continuing. And, if in 6 seconds I go down 36 floors, and in 4 seconds I go down 24 floors, whether it's 36 floors in 6 seconds, or -24 floors in 4 seconds, that both of those amount to, I'm going down 6 floors per second. 6 floors per second. It's a super secret elevator that goes really, really fast. Okay, so it's just plummeting into the earth. We're going way, way down, faster and faster and faster. Well, actually not faster and faster and faster. We're going down at the same speed all the time, 6 floors per second. But farther and farther and farther into the ground. So, in 20 seconds, right, then the 20th second, where will I be? Well, that's just 1 second after the 19th second. Okay, and now we know we're going 6 floors per second into the earth here. Go down another 6, so we're at -100 feet. Or, sorry, -100 floors. So we can continue this pattern that way, but we want to write a formula, right? So the number of floors, y, is equal to, well, if I got on the elevator and at 2 seconds into this trip, I'm on the 8th floor, must mean that I started on a higher floor than that, so that I went down to the 8th floor, right? Well, what floor would that start on? Well, that would be at time, again, time 0. 0 seconds have passed. I've just gotten in the elevator, pushed the button. It just started to move. what floor was I on when that happened? Well, I'm going down 6 floors a second. And it's been 2 seconds. I'm on floor 8, right? It's been 2 seconds. I would expect that if I go 6 floors in 1 second, I've gone down 12 floors in those 2 seconds. Okay? So I must have gone from here down 12 and gotten to 8, which means if I go back up 12, that means I was on the 20th floor when I started, and I got in the super secret elevator, started plunging down at 6 floors a second. I'm down to the 8th floor by second 2. I'm down to the negative 28th floor. I'm into the ground now at 8 seconds, down to the negative 52nd floor at the 12th second, and so on. Right? So I start on the 20th floor at time 0. From there, now we're losing altitude, right? We're going down. We're not adding to our height. We're taking away from our height. We're losing floors. 6 floors per second. So if I take negative 6 times the number of seconds, that tells me how many floors I've gone down. I started at the 20th floor. I go down this many floors, and that tells me where I am, right? So say after 5 seconds, I'm on the 20th floor. I go down 6 floors a second times 5 seconds. That's 20th floor minus 30 floors. I'm at negative 10, the negative 10th floor. That's 10 floors below the Earth. All right? That seemed like a silly story. Just trying to make one that the negative numbers made sense for. All right, so number 5. So for this one, let's say that this x variable represents hours. And because I know that there's going to be fractions involved and all that kind of stuff, I think pizzas works nicely. Pizzas work well with fractions. All right, so let's scroll up a little bit. So as we look at the hours change by 3 hours, and the y variable, which we're calling pizzas, changes by 8. As we look again, the hours change by 3, and the pizzas change by 8. Well, in previous examples, we have just taken that, let's take this one for example, that change in books, 28 books, every 7 hours, and we've just divided it. 28 divided by 7 works out to 4 books an hour. If you try that on this one, take 8 pizzas, divide it by 3 hours, well, it doesn't simplify. It doesn't become 4 or 3 or some nice number. It's just 8/3. If you were to divide it with your calculator, you get 2.6 repeating forever. And that number is about 2.6, and that's one way we can think of it. It's as simple as that. I'll just put approximately well, if it's 2.6 repeating, it's about 2.7. Of course, you know me, I'm not going to use this for very long. But we could think of it as 2.7 pizzas every hour. 2 and almost 3 pizzas every hour. That's what this could be thought of as. Well, that works perfectly fine. So I could think of it as 8/3, right? That's a fine and perfectly valid way to think of it, as the fraction 8/3 pizzas per hour, which is, just like we said, about 2.7 pizzas per hour, which is perfectly fine. It works the same as any other example. And as I increase by 4 books every hour, I just add on 4 times x. Just take the number of books that I can manufacture in an hour, multiply it by the number of hours, and I get the number of books that are produced in that number of hours. For this one, it's the same. If I took 8/3 times the number of hours, I would get the number of books that I can manufacture in that many hours, right? And that'll be part of the formula. Let's just write the formula down and then talk about it, because we've done it several times. Let's back up to 0 hours and figure out how many pizzas there were to start with. Well, if in 3 hours there were 8 pizzas made or sold or whatever, then from 0 to 6 hours, that's 6 hours. And in 3 hours, we've made 8 pizzas. So in 6 hours, we should make twice as many pizzas. We should make 16 pizzas, right? So that means that this has to be a number that I can add 16 to and get to 19. So that number must be 3. So our formula, just as it has been 4 times already, we have the beginning amount of 16. Sorry, that's not the beginning amount. 3, starting with 3 pizzas, and we add on 8/3 times x. Okay, so to understand that, we can think of it as 8/3 of a pizza every hour. We can also think of it as, well, let me show you. Let's say that I want to figure out how many pizzas I'll have at 3 hours. So notice that's in between 0 and 6. Like, it's not here on this table. Well, that's 3 hours have passed. So that's 8/3 times 3 hours. Y equals 3 plus, looks like a B. Y equals 3 plus 8/3 times 3. So I'm going to multiply 8/3 times 3. I'll put that over 1. The 3 gets divided by the 3. 3 plus 8. Well, that's a kind of a nice thing. Since I looked at it after 3 hours, multiplying by 3, we get this cancellation here, and all that's left is 8. And that fits what we already saw. In 3 hours, 8 pizzas will be made or sold. And 8 plus 3 is 11, and so at 3 hours, there will be 11 pizzas. Okay? But, as I've said a few times, if we just go 1 hour into the future, then 8/3 more of a pizza. What's 8/3 of a pizza look like? Well, here's 3/3 of a pizza. Here's 3 more thirds, that's 6/3. And here, if I try really hard, concentrate, here's 8/3 of a pizza. 1, 2, 3, 4, 5, 6, 7, 8/3 of a pizza, right? Which actually works out to 2 2/3 of a pizza. And so that's how. So I guess this place is selling it by the slice. So every hour they're selling this pizza, and they sell 2/3 of this pizza, and this third is left over to sell in the next hour, right? And so they'll sell part of that in the next hour, and so on and so on. And let's make a visual of that to see what's happening here. So like in the first hour, or in 1 hour, right, 8/3 of a pizza are sold. Well, there's this third that's still left to sell right here, right? And it'll get sold as part of the next hour, right? So they'll sell that third, and they'll sell a total of 7/3. So they'll sell 1/3. Now they're up to 4/3. Now we're up to 1, 3, 4, 5, 6. See, 4, 5, 6, 7, and that they sell another third. So here's 1 hour in blue, another hour, a second hour. 1, 2, 3, 4, 5, 6, 7, 8/3 more. And in the third hour, they're going to sell these 2/3. Okay, so they've sold these 2/3. They're going to sell a total of 8/3 in this hour. So here is 1, 2, 3, 4, 5, 6, 7, 8. And now look at that. In 3 hours, selling 8/3 of a pizza an hour, they've sold 1 whole pizza, 2, 3, 4, 5, 6, 7, 8 whole pizzas, because they've been selling 8/3 of a pizza every 1 hour. Every 3 hours, they'll sell a whole number of pizzas, because all those leftovers add up to a whole pizza in the end. Okay, so there's that one. When we have a fraction, it works the same. It's just a fraction. It just they're selling fractions of a thing, or making fractions of a thing every hour, every day, or whatever. Let's see. Let's look at this one. This one, let's see, what could this represent? let's say this x variable represents days. Let's say days. Okay. And this represents temperature. Okay, so it's getting cold, it's wintertime, and we see as the days go by, the temperature is going down. It's getting very cold. It's getting to the negative degrees. Negative 18, a very, very chilly temperature. Let's see what's going on here. In 3 days, the temperature drops. How much does it drop? Let's fully visualize this. So we've got a thermometer, right? And at one point, it's at 3. It's dropping, dropping, dropping. It passes 0. There's 0. It keeps going. It gets to -4. Very cold. So how much does it drop? Well, it goes down these 3, keeps going, goes down even further, goes down 4 more, right? So it drops 3 degrees and another 4 degrees. It drops 7. Goes down 7 degrees, right? So it drops 7 degrees, -7. If I were to subtract 7 again, I would get to -11, and that's what happens 3 days later. So now we get a feel for what's going on. It's dropping 7 degrees every 3 days. Every 3 days it's dropping 7 degrees. And on a particularly bad winter, maybe that could happen. So we're going to write a formula as we have 5 times already. Every 3 days it drops 7 degrees. But again, if I try to figure out how many degrees it drops every 1 day, I run into a little bit of a problem. It goes down 7 degrees per 3 days. 7 degrees. I guess I could write the degree symbol. 7 degrees every 3 days. So when I go to divide that, it doesn't divide very nicely. Right? I get a decimal. -7/3 is not a nice number, but it is the number of degrees that it goes down every 1 day. Every 1 day it goes down 7/3 of degrees, or -2 1/3 degrees, and that's fine. Temperatures can drop 7/3 of a degree in 3 days, or in 1 day, or 7 degrees in 3 days. In any case, we can write a formula even when this is a fraction. And as I've said several times, what I would do is back up to day 0, figure out what the temperature was then, and then start from there to write my formula. So if it was 3 degrees on day 3, and every 3 days, this is convenient, every 3 days it drops 7 degrees, it must mean that it dropped 7 degrees to get down to 3 degrees. It went from the initial temperature down to 3 degrees, and it did that by going down 7 degrees. So it went from this temperature down 7 degrees, wound up at 3 degrees. That must mean that this is 10. 10 degrees, down 7 degrees, now I'm at 3 degrees. So it starts at 10 degrees at the very beginning. From there, we're going to drop, we're going to lose, it's going to get colder, it's going to go down, right? I'm just emphasizing that we're subtracting a 7/3 times x, minus 7/3 of a degree for 1 day, right? 7 degrees for 3 days, if I were to plug in the number 3. The 3 divided by 3 is 1, so that's just 10 minus 7, and confirmation that in 3 days it'll be 3 degrees. So when you get a fraction like you do here, that's okay. It can go down a fraction every day or every hour or whatever. Y can go down by 7/3 every time x goes up by 1. That's a perfectly valid pattern. Or y can go up by 8/3 every time x goes up by 3, or up by 1, which means that y goes up by 8 every time x goes up by 3, or y goes down by 7 every time x goes up by 3. And that's just a different kind of pattern, and it's not a problem. Here we have some word problems, but it's the same idea as all those tables. So Mandy's keeping track of how many boxes of cookies she sold each day. On day 5, she sold 11 boxes. So if I really wanted to make it look like a table, I could. At day 5, she sold 11 boxes. At day 8, she sold 17 boxes. Okay, so we write a formula. Or a misspelled word equation. Should fix that. So write an equation for the number of boxes Mandy has sold on day X. Well, the number of days changes by 3. The number of boxes of cookies changes by 6. 6 boxes every 3 days is 2 boxes a day. She sells 2 boxes per day. Okay. Then we just have to figure out how many boxes did she start out with on day 0 and go up from there. That's my recommendation. So let's make room for 0 and how many boxes that must be. Okay. So now we know she sells 2 boxes every day. Well, this is 5 days, right? From 0 days to 5 days, that's 5 days of selling boxes at 2 boxes a day. That must mean she went up by 10 boxes. She sold 10 boxes in these 5 days because she sells 2 boxes every 1 day. So that means that she must have started with 1 box, right? Maybe she got her order form and she ordered a box herself, or mom ordered a box, or she just sold one right away for no good reason. Then she sells 10 boxes over the next 5 days, and now she's up to 11 boxes sold, right? So our formula for the number of boxes is equal to, let's start with the 1 box she has at the very beginning, plus 2 boxes a day times X days. 2 boxes a day times X days. And now we're going to use the formula to see how many she sold on day 32, so we just need to plug 32 in there. Y equals 1 plus 2 times 32. Y equals 1 plus, this is going to be a 64. And so on day 32, she sold 65 boxes. Okay, exact same kind of idea here. So Rufio's keeping track of the leaves that fell off his apple tree last fall. On 5, he counted 38 leaves still on the tree. So day 5, he's got 38 leaves. And this is X and Y. Day 5, 38. On day 9, there are 34 left on the tree. So now we're going to figure out how many leaves are falling off each day and use that to write a formula and then to calculate how many are in there on day 23. So days increases by 4, right? From 5 days to 9 days is 4 days. From 38 leaves to 34 leaves, that's 4 fewer leaves. 4 leaves came off the tree between those 4 days. So just 1 leaf per day, right? We lose 4 leaves in 4 days. That's -1 leaf a day. All right, so that's how the leaves are changing. Apparently that means that they're falling off. How many leaves did we start with? Well, 1 leaf per day, just 1 leaf per day. If we back up to day 0, that's 5 days. Right? From 0 days to 5, day 5 is 5 days. What's been happening over those 5 days? The tree has been losing a leaf a day. So that means it's lost 5 leaves and has come down to the number 38, which means that it must have had 43 on day 0. 43, we come down 5, and we're at 38 leaves. Okay, so our formula will look like y equals, start with 43, lose 1 leaf per day times the number of days that go by. Okay, we'll use this to figure out how many are still on the tree on day 23. That's y equals 43 minus 1 times 23 days later. That's 43 minus 23, and y equals 20. 43 minus 23 would be 20. So there's 20 leaves on day 23. All right, so that's all the examples from that quiz. If you have any questions, absolutely come by, talk with me, sit down, we'll have a chat, and straighten out any confusions. Thanks for watching.